Okay, hello guys. Today I'm gonna show you how to operate the trigonometry and its function. Just like the sine, cosine, tangents, and so on. Like the arc cosine. Just for example, here, if you are familiar with the trigonometry, okay. First one, if you didn't import the numerical platform, just type the import numerical platform. Or you could create the name of this, just like MP. Okay, let's get started. MP dot sign. Just type the SIN. MP dot pi over 2. So you should get 1. Because sine pi over 2 is 1. Sine pi over 2 equals to 1. Or 1.0. 1.00. 1. So the output here is 1.0. Is the double an integer here. Python does not have the data types called double. Yes. And the next if you want to use the array, I mean more than one values, 3 mp.pi 4. Let's see the results. 0.866 and 0.7 because here's the one property of the sine function, pi over 2, from pi over 2 to pi. Hold on. From pi over 2 to 0 in sine here decrease. It decrease here. I hope you guys understand what I means here. So 0.866, 0.707 here. So it's the common sense here. Okay. If you want to convert degrees into radian, how do you do that? Just for example here. Y is MP degree. Hold on. Degree to radian. X. So print one. Yeah. It means degree to radian. If we want to convert radian to degrees, how do you do that? Just change the name here. Radian to degree. And here you should change the number. Just if I copy this here. So hold on. Should have the comma to separate them. Yeah. So it's pi over 2. Yeah. Radian degrees, radian 2 degrees. Okay. How about arcsine? X is mg dot ARC1. Sine is 1, so it's pi. Yeah, it's here. We will use arcsine, cosine, arctangent. Find the angles here. Okay. Because here sine arcsine 1 is pi over 2. So 3.141415 over 2. So it should give you the 1.57 blah 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 is so it also works for the arccosine arctangent here. Okay, the next one. Have you ever learned the hypotenuse? Just like sine h. Sine hypotenuse. So base is 3. The next one just is force. X is ampere dot heat for 3, 4. It's not sine h here. So 5.0 here because it means v squared plus 4 squared is f equals period here. So it's easy here. Yes. Just type the HYPOT. Okay, the next one. I'm gonna show you the hyperbolic versions. For example, cosine h, tangent h, sine h, cosecant h, secant h, or tangent h. Hyperbolic, cosine hyperbolic. Yeah, easy here. So copy this and just put the h here. Yeah, it's easy here. How you guys if you don't know the range of the cosine this hyperbolic function or the domain, you could check on the formula here. So it's valid here. The sine h because the sine h is like this thing. Okay. So we also have arcsine h, arccosine h, arctangent hyperbolic, and so on. Is the mathematics. Yeah. or if you want to use if you want to give more numbers, use the list or the tuple. np.py over for example here. Then the last one. I'm gonna show you the set operation. If you know the set theory, here, for some of the set theory, you don't need to know the whole bunch of the topics in the set theory. Just select thing. ARR is np dot array 11112345579 x equals to np dot unique. Yeah. So this is unique. Just find the distance numbers. Yeah, distance numbers. The next one. ERR1. mp dot array 135. Union. You can't use the plus because the plus means addition in numerical Python. Array method. I've just shown in the previous video here. If you want to use the union, just type union. And I missed one. So here's 1D. You need to put 1D. If you don't put 1D, it just have the attribute called the union. 1D E. Okay. So 1, 2, 3, 4, 5, 6, 6, 7, 9. How about the intersection? Okay, X is UMP dot intersects 1D, one dimensional. You think about like one dimensional. Array one, array and array one. Here X 135. Or you could put one more argument. Assume unique. So 111355. Yeah. 111355. Here. Yes. If you want to set the difference, here, set EIFF. So how do I call this exclusive OR? If you know the exclusive OR, the XO exclusive, yeah, it means the exclusive OR. Yes, exclusive OR here. Just means the two sets cannot uh the set. How to explain? You could check it from the online here. If you don't know what the XOR means, find the difference. I can show you that here. Or symmetric. Also, it should be XOR. Same thing. Okay. The values they are not present on the both. Oh wait, both these, both sets. Yes. Okay. So that's the end of this numerical. Oh, I missed two things here. If you want to set the zero, you use the zero. NP, if you want to set the arrays is all the zeros, use the zeros. Here, 3 by 3 matrix. And index, so 3 by 3 matrix, all zero. Yeah, it's easy here. And you could use ones. All is ones. One, ones. But only zeros and ones. No twos, threes, and so on. So you can't use twos, threes, fours, tens. Only ones and zeros. Yeah, just like the by default. So here's one. I can show one example. Interesting examples here. If I create 4 by 4 matrix, 4 by 4 matrix. So it should be one or ones. If I want to change these 4 ones to be zero, how do I do that? Just I means if I change the inside to be the zero, inside of the ones to be zero, use this. I could slicing the index. So from one, yes, from 1 to 3, from 1 to 3, comma, from 1 to 3, all to be 0. I hope you guys can figure this out here. From 1 to 3, so 1, 0, 1, 2, 3, 1, 2. So we select these two away, these two in these two lists, and inside these two lists, I'm gonna select 1, 2, 3. So 1, 2, 1, 2 to be 0. 0. So it's an interesting feature here. Yeah. So that's the end for this numerical 5 Thank you for listening.